Okay, I think we are recording. This is CSSS 508, week 1, our studio and our markdown. My name is Brian Haskett, and this is the re-recording of lecture from week 1, as the in-class recording didn't quite sync up the audio kind of at all. Yeah, so let's get started. The course goals for this class are first to develop intermediate data management and visualization skills in the R programming language. We're also going to learn some basic programming, introduce reproducible research practices, and prepare you for statistics and CSSS courses. Who am I? My name is Brian Haskett. Brian rhymes with neon, just call me Brian. I'm a 5th year sociology PhD student. My research interests include labor, collective action, pay-setting institutions. My methodological interests include econometrics, counterfactual reasoning, computational data collection. I'm also very interested in reproducible research practices all the way at the data collection stage. That's part of the reason I got into R so much. A little bit about me. I write code every day. I really enjoy all of the little wins that coding provides. I'm a nerd, but only between the hours of 9 and 6. I say that to say I will only be answering emails between the hours of 9 and 6 for answering Slack messages, mailing lists, that kind of thing. I also really am a strong believer that social science programming is magical. The social element of social science programming means that so much of our programming practices are not focused on efficiency, but are rather focused on reproducibility and shareability and being able to have collaborators who don't quite understand all of the nuances of statistics be able to run the same format and script and come out with the same results. Logistics about the course. The location will be in Savory 117, the big lab down there by Caesar on Wednesdays, 3:30 to 5:20. The recommended lab will be in the same room on Mondays, 3:30 to 5:20. And my office hours will be Tuesdays from 9 to 11 via Zoom. And I will keep my office hours via Zoom so that you can share your screen, for instance, and also so that I have access to my big computer and not my very old laptop. All of the course materials are going to be available on the course website that I have hosted through GitHub. Grading for the course. The final grades are credit, no credit. 60% of all of the credit in the course will get you a credit grade. Homework most weeks will count for 75% of your grade. There'll be a combination of reading and programming and writing up little reports. Well, some are not so little. Peer grading will account for the other 25% of your grade, and both of these things will be handed in on Canvas. Canvas is only going to be used for submissions for this course as it makes grading very easy. Everything else will be kept on the course website. So on peer grading, yes, we're doing peer grading because you will write your reports better, knowing that others will see them. You learn alternate approaches to the same problem by seeing how your classmates have come up with different solutions. The format will be randomly assigned peers, and it will be due before the following Wednesday, following the grading rubric that's available on the course website. Be sure to leave constructive comments, more than just good job. More than just good job. More than just good job. On assignments 1 through 3, I expect a few sentences at least, talking about the ins and outs of things that you've seen in their code. Assignments week 4 and up may follow the labs almost exactly, if not piece for piece, and will need less feedback if they are in fact perfect. Be sure to email me if you want more feedback or if you felt like one of the peer grading gave you a 1 out of 3, but you deserved a higher grade, something of that kind, I'll be happy to personally grade it if you'd like. Materials for this course are on the course website. This includes the slides and the code used to generate them, an R script for the slides to follow along in class, PDFs of the slides if you would prefer that instead of this HTML format, like how I'm sharing my screen right now. This includes all of the instructions for the homeworks and the homework templates for weeks 4 and up. Video recordings of the lectures, like this one that I'm re-recording, and the labs. We will be troubleshooting the first couple weeks. As you can see, we're not in Savory 117 in this video. There's also a lot of useful links to other resources, primers that are relevant to each of the weeks or under each of the weeks. Please check those out. If you find something on the website that doesn't work, please Slack me, email me. I've ported a lot of this website from my colleague, Chuck Lanfear, who used to teach this course. And I reckon that some of the links are, I don't know, leading to nowhere. About the lab. Lab is optional, but recommended. For labs 1 through 3, I will provide general technical support and answer any R-related questions you have, whether they are for homework or not. For labs 4 and up, in the latter 2/3 of the course, we will walk through homeworks together. This provides students guidance through the more complex homeworks, and the setup in its entirety gives students the options of 1, working independently on homeworks for maximum learning, 2, reserving homeworks for lab if they are too challenging or time consuming, or 3, a bit of both. About using the mailing list. Don't send things to the mailing list in this format. I tried LMY by X, but it didn't work. Instead, ask like this. I made this data Y out of the sequence function and the drawing from normal distributions function, as well as this data X from the sequence function. And I tried to run this linear regression model. Running the block all above gives me the following error. Does anyone know why? And I be able to say, well, this has 11 elements in it, and this one only has 10. So you're not going to be able to run a linear regression on it. If you're not enrolled and you want to be on the mailing list, please email me. The Slack channel. This course uses the Slack channel for additional communication. You'll receive a link to join via the email list, which you should have already gotten by the time I'm recording this on Friday. You'll receive, I already said that, use it like the mailing list to ask questions, particularly for short questions. You can just come in and say, I don't quite understand how the filter function works. And give a little brief description. For instance, use the mailing list for long questions or those that require you to attach a file. I also encourage you to answer each other's questions. One thing about the Slack I will note is that it's actually the same Slack for all the years that have taken this course in the last, I don't know, year or two or three. So there are people in there who took this course and now are just there to answer questions or provide some of their own questions about work that they're doing right now. So it's a very collaborative space. It's very social science centric, and it's great. I don't know. I wanted to plug Caesar. We are currently next door to Caesar. Well, I'm not. Savory 117 is. Savory 110 and online Caesar is available for one-on-one software and data management and quantitative and qualitative coding consultations. The Center for Social Science, Computation, and Research, that's what CSSS stands for. They offer excellent consulting services for R. I was actually just in there today trying to make sure I could get the microphone to work for next Wednesday so that I don't lose my voice again. I haven't been expected to talk above a whisper for going on 2 years now. So it was quite difficult, but hopefully we can get that microphone ready for next week. A note on slide formatting. On the slides, bold usually indicates an important vocabulary term, so remember these. Italics indicates emphasis, but also are used to point out things you must click with a mouse. For example, please click File, Print. Code blocks represent our code you type into the editor or console, or keystrokes used to perform actions. For example, press Ctrl+P to open the print dialog. Code chunks that span the page represent actual R code embedded in the slides. So this is R code. You can copy paste if you're following along that way. The lines preceded by 2 pound signs or 2 hashtags represents the output or result of running the code in a code chunk. We will talk about more of this later. The lecture plan will be as follows. This week, we're talking about RStudio and R Markdown, and what these things are, how they function, how are they relevant to us. Week 2, we'll talk about visualizing data, where we will be working within ggplot2, the tidyverse-centric graphing package. Week 3, we will be talking about dplyr, which allows us to manipulate and summarize data of great importance to us as social scientists. Week 4, we will sort of turn back to the building blocks that we've been using to make all our graphs and summarize data. The R data structures, so all of our different data structures that we will be messing with, and getting a understanding of how each one of them functions in specific. Week 5, we'll be doing data janitor work. So this is importing, exporting, and cleaning data. This is often the most time-consuming part of social science coding, is just making sure that all of the variables and things are uniformly clean. For instance, I am working on this project where they asked many domestic workers questions about their work lives, and the data set that I got was part in Spanish and part in English, and there was very many different people who wrote down all of the answers, so I had to clean all of the data so that answers that were in Spanish were comporting with answers that were in English and all of that. And that was by far the most time-consuming part of the project, because after that, making the requisite tables and graphs and things was trivial. Week 6, we will talk about using loops. Week 6 is important because loops transfers to many coding languages, but we want to throw it out almost immediately. We're learning about loops so that we can learn about how we can move beyond them. Week 7, we will talk about writing functions. Functions is one of the keys to really strong reproducible research in R. Week 8, we'll be working with text data. This will be things like regular expressions and the stringer package in the tidyverse for how we're going to manipulate character data. In week 9, we will talk about geographical data and how we would go about putting things on a map in R. And finally, in week 10, we'll talk very explicitly about reproducibility and model results. We only talk a little bit about modeling results because this class does not assume that you have any knowledge of linear models or ANOVA or any sort of statistics. So I don't want to bombard you with a bunch of things that maybe doesn't quite make sense to you at this point. But I want to expose you to some of the tools that people use for model results, so that going into your next CSSS classes or CSD classes or what have you, you have some exposure to how that works in R. Okay. About R in RStudio. Why R? R is a programming language built for statistical computing. If one already knows data or similar software, why would I want to use R? First, first, R is free. So you don't need a terminal server. You don't need to pay so many dollars a year for anything. It's just there for you to download. Second, R has a very large community. Go check out like the R Studio subreddit or the R Stack Overflow section. You'll see very quickly how wide the distribution of people who use R is. R can handle virtually any data format. I will challenge you, if you encounter a data format that you think R cannot handle, please send it to me and we'll see if that's true. R makes replication easy. One such example is if you go to like the Harvard Dataverse, many things are just quickly reproducing papers in R. It's very fun and neat to see research that just gets ported quickly. Highly recommend. But because of the format of scripts and markdown pages, it's very easy to reproduce and replicate research. R is a language, so it can do everything. Whereas in other statistical computing packages, they might say be unable to produce an R markdown report, for instance, or be able to connect with other coding languages as quickly and as well as R does. R skills also transfer to other languages like Python and Julia. Very quickly, I found it very quick to pick up Python after I'd learned R. Same with SQL. I can't speak to Julia in specific, but I have heard through the grapevine that that is true. A note about R Studio now in reference to R. R is just the programming software that underlies R Studio. R Studio is a front end or integrated development environment for R that can make your life easier. So R Studio is the software that we're going to be using so that we don't have to use basic R. R Studio can organize your code, outputs, and plots. It can autocomplete code and highlight syntax. It can help view data and objects. It enables easy integration of R code into documents with R Markdown. It can also manage Git repositories and run interactive tutorials and handle other languages like C++, Python, SQL, HTML, and shell scripting. So on to selling you on R Markdown. So one of the advantages of R that I've talked about is its ability to produce reports through R Markdown. The ability to create R Markdown files is a powerful advantage of R. Document analyses by combining text, code, and output into one script. So no more copying and pasting into Word. This allows for easy collaboration. It's easy for collaborators to understand what's going on through each part of the report. And you can show as little or as much code as you want. It's able to produce many different document types as output, PDF documents, HTML web pages and reports, Word and PowerPoint documents, and presentations like the slides, which I'm showing right now. It also works with LaTeX and HTML for math and more formatting control. So R Markdown is a function within R that allows us to produce reports. We'll get back to that shortly. So getting started, we're going to open R Studio, choose File, New File, R Script, and then let's get oriented with the interface. So I'm going to pull it up. We are going to choose File, New File, R Script. And this is more or less what your interface will look like. In the top left, here we have the editor pane. This is actually like a script file here, where you can write code and it will stay there. In the bottom left here, we have the console. This is for running code that is going to not get saved. You'll note that on my home computer, my R version's a little bit old. That's okay. In the top right, we have the list of objects in the environment. Right now, our environment is empty, as well as our history tab. So this is all the things that I've been running as of late. Yada, yada. And then in the bottom right, we have tabs for browsing files, viewing plots, managing packages, and viewing help files. So here, I've already navigated to our week 1 lecture file, which has our slides in it, for instance. You can see it on my GitHub. You can change the layout and preferences, pane layout. I'll show you where that is right now. So we go to global options, pane layout is one such way. And you can see you can change it here by using these little drop downs. Great. I personally am not a fan of the default layout and always change my panes. But for the purposes of our learning, I will grit my teeth and use the default layout. Okay, about editing and running code. There are several ways to run our code in R Studio. You can highlight lines in the editor window. That was the one in the top left. And click Run at the top, or hit Control Enter, or I still haven't figured out what the name of that thing is, the Mac swirly Q plus Enter, and run them all. Another way is with your caret. That's this little flashing guy here. With your caret on a line, you want to run, hit Control Enter, or Mac curly Q Enter. Note your caret moves on to the next line, so you can run code sequentially with repeated presses. You can type individual lines of code in the console and just press Enter and it will run. In R Markdown documents, you can click within a code chunk and click the green arrows to run the chunk. Excuse me. You can click within the code chunk and click green arrows to run the chunk. The button beside that runs all prior chunks. The console will show the lines you ran, followed by any printed output. About incomplete code. If you mess up, something like leaving off a parentheses here in this math calculation, R might show a plus sign, prompting you to finish the command. You'll run into this a lot, especially when you're new. You can finish the command or hit escape to get out of this. So R also functions as a calculator, and a pretty strong one as well. In the console, you can type 1, 2, 3, plus 4, 5, 6, plus 7, 8, 9, and hit enter. I'll show it off right now. So here in the console, we can do 1, 2, 3, plus 4, 5, 6, plus 7, 8, 9, and press enter, getting the exact right answer. The 1 and the output indicates the numeric index of the first element of that line. We'll talk a little bit more about that as the course moves on, but keep an eye out for that. Now, in your blank R document in the editor, try typing the line square root 400 and either clicking run or hitting Control plus enter or Apple curly Q plus enter. So we go up to the editor and we could hit run, for instance. We'll note that down here in the bottom left, it says the answer is 20. We could also highlight and hit Control enter and we'll get the same answer. We could also just have our caret on the line that it's on and hit Control enter and it will also run. Great. a little bit about functions and help. Square root is an example of a function in R. If we didn't have a good guess as to what sqrt, open parentheses, close parentheses, will do, we can type question mark, the function without the parentheses in the console, and then look at the help pane on the right. So let's go ahead and try that. I'm going to copy paste, go here, go to the console. Again, I don't have to hit Control Enter because I'm putting it in the console rather than the editor. Hit Enter, and then here in our help pane, it tells us square root computes the principal square root of x, square root of x. The naming follows the standard for computer languages such as C and Fortran. So these are very old computing languages, and it's following those conventions. A little bit about our help pane here. It will tell us a description of what our function is doing. It'll talk about how it's used, what an example of that would be. It'll say square root is used by putting an x here, and the x being an argument that takes a numeric or complex vector or array. Down here, we'll also usually offer some references of a book you might be able to check out and see where they came up with this idea. And oftentimes there is down here a example of how the function operates. Okay, arguments are the inputs to a function. In this case, the only argument to square root is x, which can be a number or a vector of numbers. Help files provide documentation on how to use functions and what functions produce. Great. About creating objects. R stores everything as an object, including data, functions, models, and output. Creating an object can be done using the assignment operator, which looks like an arrow pointing to the left here. So for instance, you can make an object called new.object and use the assignment operator to assign it to the number 144. Okay, so I will go to the editor pane. I'll paste that in there. And since my caret is already on the line, I can just hit Control Enter. And then you'll notice in our environment, it is no longer empty. There is now an object called new.object that has the values 144. Operators, like the assignment operator, are functions, like our square root function, that look like symbols, but they typically sit between their argument. The arguments being something like numbers or objects. This is instead of having them inside of parentheses, like in the case of square root. We can do math with operators, something like x plus y, where plus is the addition operator. About calling objects. You can call or display an object simply by using its name. So if you take new.object and run it, you'll notice down in the console, it outputs 144. This is calling the new.object object. Object names can contain an underscore and a period in them, but cannot begin with numbers. I said in class, 21 Savage is out. Deltron 3030 though. Takeshi 69. Come on. Try to be consistent in naming objects. RStudio autocompletes RStudio's autocomplete means that long names are better than vague ones. Good names save confusion later. Okay, a bit about using objects. An object's name represents the information stored in that object. So you can treat the object's name as if it were the values stored inside. A few examples, you could say new.object plus 10, and the output will be 154. You can say new.object plus new.object, and the output will be 288. The square root of new.object is 12. Okay, creating vectors. A vector is a series of elements, such as numbers. You can create a vector and store it as an object in the same way. To do this, you use the function lowercase c, open parentheses, close parentheses, which stands for combine or concatenate. I will highlight again. I am used to saying concatenate for lowercase c. I've heard others say combine. You will often hear me say concatenate. So we could, for instance, assign to new.object a vector with 4, 9, 16, 25, and 36 as its elements. Note they're separated by commas. So I'm going to go ahead and do that. And then you'll see in the environment, new.object has between 1 and 5 elements, 4, 9, 16, 25, 36. If you name an object the same name as an existing object, it will overwrite it. This is very important. If you name an object the same name as an existing object, it will overwrite it. So recall 3 slides ago, new.object was the value 144. That is gone. New.object now represents this vector of 5 numbers. Bear that in mind as you assign things to objects, that you're not going to be able to get 144 back if, for instance, you did it in the console or something. You can provide a vector as an argument for many functions. So we could use the square root on our vector object new.object. And note that it goes through each element of our vector and runs the function for each one. So we have 2, 3, 4, 5, 6 are each the square roots, respectively 4, 9, 16, 25, 36. There are more complex objects. The same principles can be used to create more complex objects like matrices, arrays, lists, and data frames. Data frames are lists which look like matrices, but can hold multiple data types at once. If these bunch of names is maybe a little bit overwhelming, that's okay. Right now, we're going to get through it, and we're going to learn what each one of these things does, and it's going to be fun. Most data sets you will work with will be read into R and stored as a data frame. So this course will mainly focus on manipulating and visualizing these objects. Before we get into these, let's revisit R Markdown, which is our tool for producing reports. Here is R Markdown. Okay. R Markdown documents are a type of file that you can produce in RStudio, much like our R script that we opened up earlier. So let's try making an R Markdown file, shall we? We are going to go to File, New File, R Markdown. Our title isn't particularly important right now, so we're just going to call it my first Markdown. Right, yeah. And we're picking HTML as our output format. I want to note that while PDF seems enticing right now, excuse me. While PDF seems enticing right now, it does require that you do a little bit of setup in order for that to work. particularly on Windows machines. Word should work right out of the box. Okay, so we are opening our Markdown. We gave it a title. I'm the author. We are picking HTML as our default output format and click OK. So now we've produced this document inside of RStudio. We want to save this file somewhere. So I'm going to hit file save. It doesn't particularly matter where it goes. My first rmd.rmd. Great. So that has been saved here. Next, we're going to click knit HTML button. This is here. You'll see it is next to this little ball of thread and needle. So if we hit knit, we can watch the progress, all of this stuff going on under the hood while our Markdown produces a document for us. And we'll see that it has come up in our viewer pane, our default first Markdown. You may also open up the file in your computer's browser if you so desire, using the Open in Browser button at the top of the preview window, which will be right here. Great. Okay, how do I open back up the slides? Here. Okay, that's our Markdown document. A note about our Markdown headers. The header of a .rmd file is a YAML. YAML is actually a separate coding language. YAML stands for YAML ain't markup language. The code block and everything else is part of the main document. You'll see that it'll look something like this. Note, like I said, a lot of this content is ported from Chuck, who taught this class before, Charles. To mess with the global formatting, so this is the format of everything in your document, your R Markdown document, you should change the YAML in order to accomplish this. One such way you can do that is example here. So note, this is our YAML. You'll see that it's between these three hyphens on top and bottom of it, right at the top of our Markdown document. We copy pasted that example from the slides. And if we hit knit now, we'll see, does its work. And over here in the viewer pane, we have a little bit more legible font. So there are a lot of options you can use to change your YAML so that your whole document changes. This is one example. A note also, be careful though, YAML is space sensitive and the indents matter a lot. So each one of these is just one space farther away from the line than the other one. And Readable does not have a space on the other side of it, but is one space away from here. Okay, a few things to provide you with for Markdown syntax. If you want to bold something, you want to give it 2 asterisks on either side of the words. Italics is just 1 asterisk on either side. Headers have a £, a space, and then the words. Subheaders have 2 £, a space, and then the words. And a subheader has 3 £, a space, and then the words. If you want to block quote something, you want to give it that little right-facing arrow, a greater than. More R Markdown syntax. If you want to create an ordered list, you just use the number 1 before your content. And if you want it to indent, you just want to space it over 1. The unordered list is 1 asterisk and then a space, and then your words. This is different than the italics, which the asterisk should be right next to your words. To put URLs within the R Markdown document, you want to put what the link will say in brackets, and then the link to the website in parentheses right after that. You can do this with pictures as well. Goodness me, I didn't fix this before re-recording this. But you just put an exclamation point before the same setup as the URLs in order to put pictures in like this little W. Note that you can give it a caption by putting in the brackets a caption. And then here you can put something like, excuse me, you can put something like a link to a picture on a website or a link within your directories that you're working from. I'll note about formulas and syntax. You can use LaTeX style math within lines by using $1 on either side of it. So you can put some math for y equals 2/3 squared. Or if you'd like to have a chunk of something like the arithmetic mean, you can put in backticks and then $, your LaTeX. Or you can put a sentence with code font in it by putting the words in backticks. Backticks, I should note, are the button right below the escape key in the top left of your keyboard. I'm sure you've gotten virtually no use of it if you are brand new to coding, but it's nice to get full use of your keyboard now. You can also make a block of code output to look like code in your document by doing 3 backticks, then your code, then 3 more backticks on the next line. For R Markdown tinkering, there are a lot of ways that documents can be modified. Visit these links for more information. Highly recommend the R Markdown Definitive Guide. Following those steps is how I created the course website and fixed these slides. Some formatting caveats. To keep R Markdown dead simple, it lacks some features you might occasionally want to use. Your option for fancier documents are templates. For instance, our course website takes advantage of templates in order to give it that cool drop box. Very proud of that. You can use HTML with CSS for custom formatting. HTML and CSS is how, for instance, these slides are able to have this really cool purple box and UW CSSS right down at the bottom. You can also use LaTeX and Sweave files instead of .markdown files. LaTeX is kind of archaic, but if you know somebody that's good at it, keep them around. For day-to-day use, plain old R Markdown does the job. For handouts, memos, homeworks, default R Markdown PDFs look surprisingly good. Note these slides were made using Sharingan, like the Naruto thing, Sharingan, but with an X. Check it out. Sharingan is pretty cool. A little bit about how to put R code in specific within your R Markdown documents. So inside R Markdown, lines of R code are called chunks. Code is sandwiched between sets of 3 backticks, which are followed by a curly bracket, lowercase r, curly bracket. For instance, this chunk of code, 3 backticks, curly bracket, lowercase r, curly bracket, then summary cars, and 3 backticks. Produces this output in your document. So you run that chunk, it'll produce this output. A few of our chunk options. Chunks have options that control what happens with their code, such as echo equals false, which keeps our code from being shown in the final report that R Markdown creates. There's eval equals false, which shows our code in the document, but it doesn't run the contents of the R code. There's include equals false, hides all output, but still runs the code. This is good for setup chunks where you load packages or load in your data, for instance. There's results equals hide being surrounded by apostrophes. This hides R's non-plot output from the document. There's also cache equals true. Cache, is it cache? I feel like it's cache. Cache equals true. This saves results of running that chunk. So if it takes a while, you won't have to rerun it each time you reknit your document. There's one project I'm working with the Harry Bridges Labor Center on, where I'm taking advantage of cache equals true because it's quite a lot of American Community Survey data. And if I just want to, putz around with the graphs or tables, and I just want to adjust the way they look in the reported document, I don't want to have to rerun this, 10 gig file every time I want to output the document and look at it again. Within the code chunks, you can also specify how big you want figures to be. This was really great when I was trying to write my master's thesis and I wanted the graphs to fit in next to each other and not misalign paragraphs and things. Some of these can be modified using the gear-shaped modify chunk options button in each chunk. There are a lot of other options, however. Be sure to click this link when you check out the slides that are on the website. I should probably point out where the modified chunk options button is. So here we have a chunk. Note that it does still have this 3 backticks, then a curly bracket, lowercase r setup. But then the name of the chunk is here. There's a comma before a chunk option, and then there's the closed bracket, the closed curly bracket. And then there is the contents of the R code. This is R code from the knitter package, and 3 more backticks. And that's kind of the anatomy of this chunk, but you can click this and it will provide maybe more legible descriptions of how you might want something to in your chunk to work. So you can say show output only, or show code and output, or show nothing, but don't run the code, for example. So a little bit of playing with chunk options. Try adding or changing the chunk options separated by commas. They want to be separated by commas for the 2 chunks in my first rmd.rmd and reknitting to check what happens. You can also name your chunks by putting something after the R and before the chunk options. Okay. So, for instance, we could say eval equals false. And then if we wanted to add an additional chunk option, something like cache equals true, we would want to have a comma in between each of these options. And then if we knit, kind of giving it strange directions right here. We'll note that the eval equals false means that it's not going to run the content of the code, but it will show what it is. So that's why this is just here, but there's no output like the one here. And cache equals true means that if we were to reknit the document and change it, it would not evaluate this chunk again because it's sort of saving it for whenever the report comes out. A note about naming your chunks. You can also name your chunks by putting something before any of your chunk options. And note that after you name your chunks, you can see what happens in the drop-down menu in the bottom left of your editor pane. Naming chunks allows you to browse through an R Markdown document by named chunks. You can also browse by sections using headers and subheaders. So I'll show that a little bit. So this was named cars. We can name it cars chunk. And then if we go to here, the bottom left of our editor pane, it will show our chunk 1. It's called setup. If you'll recall, that had the knitter R code in it. And then chunk 2 is now called unevaluated cars chunk. And then there's a chunk 3 called pressure. And if we click, it will put our cursor right there. Also note that this says including plot and R markdown in my first markdown. This is related to this subheader here and this subheader here. And then there's also the title constitutes a header in this particular markdown document. We can use inline R code. Sometimes we want to insert a value directly into the text of what we're writing. We do that using a code, using code in a single backtick, starting off with a lowercase r. So this is an example of something you could write within your document. 4 and 7 years ago is the same as backtick, lowercase r, some R code, 4 times 20 plus 7, and then another backtick, years. And our output will look like this. 4 and 7 years ago is the same as 87 years. Why don't I go ahead and show you what that looks like in the document. So let's just, right here, see 4 and 7 years ago is the same as backtick R 4 times 20 plus 7 years. And then if we knit, we'll see that it outputs 4 and 7 years ago is the same as 87 years. Maybe we've saved a variable in a chunk that we want to reference in the text. So we could say something like x will be assigned the square root of 77. And the value, and then we can write a sentence in the content of the document that says the value of backtick x rounded to the nearest 2 decimals is R code, as denoted by this backtick, and then immediately a lowercase r. Round, the round function just rounds numbers. And then our assigned object x, comma, and then an argument here 2 tells it that we want it to the nearest 2 decimal places, and then another backtick before a period so that it knows to finish the R code or checking for the R code while printing out the document. The value of x round to the nearest 2 decimals, 8.77. Why don't you go ahead and try that one at home? This is amazing. Having R dump values directly into your document protects you from many kinds of silly mistakes. You never have to wonder, how did I come up with this quantity ever again? Just look at the formula in your markdown file. There's a lot of consistency. There's no find and replace mishaps. You can reference a variable in line throughout your document without manually updating it if the calculation changes. For instance, if you have to change the reporting of your sample sizes for something. You are also more likely to make a typo in a hard-coded number than you are to write R code that somehow runs but gives you the wrong number. I think this is great. An example is keeping dates in your YAML header. Make the date come from R's sys.time function by changing the date that's there to this. And you'll note that it will print out the exact time that you knit the document. So I'll show that off right now. Excuse me. So we're going to the date and we're going to put the sys.time function and then we knit. And then now it tells us the exact system time. Still today's date, but it also tells us the exact time that the document was created. And if we knit again, it updates the time. And so being able to do something like that is actually how our slides say what the date is, which is the date that I suspect that we're going to give the lecture, but also it says updated, and it's updated the last time that I knit the document. Okay, on to data frames. In the sample R Markdown document you're working on, we can load the built-in data cars, which loads as a data frame. This is a type of object that we've mentioned earlier. Then we can look at it in a couple different ways. Okay, so we can use data, the function data, and the argument cars loads this data frame into the global environment as a promise. So let's go. We should probably show this. And then in the console, I'm going to type data cars. When I run that, see here that it says promise rather than telling me, something about the numbers or something about what the cars data set really is. And promises are unevaluated arguments. And unevaluated arguments are when I forget to take the chicken out of the freezer and then I remember, and then my lady gets off work. I'm joking. To read more about the lazy evaluation of R, there's a really great link here. You can use the view cars to pop open the viewer pane. This is for interactive use only. Do not put this within your Markdown document. Don't put view in your Markdown document, ever. Don't do it. Note that this one is with a capital V. I recall that in class, somebody asked me, when am I going to know that functions are supposed to have a capitalization or not? Very rarely, if ever, do functions have capital letters in them. View is a holdover from a time where there wasn't a best practice of having them all be lowercase. So I would say that the majority of the time, your functions are all going to be written in lowercase letters, and you will quickly pick up on the very old form functions that are like view here. But let's go check out view. View cars, and we'll see that cars data set has a speed variable and a dist variable, and it has some values, and there are 50 rows. Over here in our environment, it now says cars has 50 observations of 2 variables. Great. We can use head, cars, and then 5 to print out the first 5 rows. You should also see tail. Tail is an important one as well. What head does is it just shows the first n amount of rows in your data set. So if we go down here to the console and we type head, cars, comma, 5. Note that it prints out the first 5 rows of your data set. This is really useful when you want to check if something has been done, but you don't want to view because view will take a long time on really, really large data sets. Or you can say tail, cars, 5. And I'll show you just the bottom 5 rows of your data set. Note also that you could just say cars, and it'll print out 6. It defaults to 6 rows for reasons I do not know. I tend to specify 10. Tell me more about cars. So if we want to learn more about the cars data set, we can display the structure of the object using the str function. Str is short for structure. Go here, str cars. We'll see that it is a data frame with 50 observations and 2 variables. The 2 variables are speed and dist. They are numeric data types. And here are the first 10 or so observations in each of the variables. We can also use summary. This displays summary information. I know, so confusing. Summary will tell you a little bit about your variables, but note that R is object oriented. So summary provides different information for different types of objects. So as you move forward in this course, I recommend you just try summary on different objects that we mess around with and check to see what kinds of information that gives you. I think you'll be surprised. You'll be pleasantly surprised. I don't think it'll be unpleasantly surprised. Okay. We can make ugly pictures of the car's data frame using the hist function. This generates a histogram of a vector. Note you can access a vector that is a column of a data frame using the $sign, the extract operator. Okay, so extract is an operator that takes two arguments. On one side will be some sort of object, and on one side, something inside of that object. So we can put this to show quickly how to make a histogram in base R. Great. They are not good. This little space here is very confusing to me. It's very unpleasant. But that's base R for you. We can draw slightly less ugly pictures by providing more arguments to our function. Okay, so we can add xlab equals distance in feet, and main equals observed stopping distance of cars. So if we run this, great. It'll populate just like that. And you might be saying to yourself, how am I supposed to know that it says xlab and I don't write x label or x axis or what have you? If you go to (hist), it'll tell you what arguments it can take on. So first, the description, the generic function hist computes a histogram of the given data values. If plot equals true, the resulting object of class histogram is plotted. Okay, and then its arguments that it can take. First, it takes a vector of values, which the histogram is for which the histogram is desired. In our example, we had our distance variable. You can specify which breaks you want to have on the axes. But here, one of our available arguments that we can give the hist function is main and xlab and ylab, and note that they've been bundled together so that you can sort of treat them the same way. This is the main title and axis labels. These arguments to the title function get smart default values here. Something like the default ylab is frequency if and only if frequency is true. I would note that with a lot of the base R functions, these help panels might seem a little bit confusing. There is maybe a lot of it confusing. I read this and I'm still just like, okay, yeah, but once I do this, what happens next? There is a link on the course website that's about how to read the help panes on R. So check that out. We can do math with the cars data set. If you put an assignment such as x, assign y to x in the parentheses, R will print the output of the assignment for you in your document. Otherwise, it won't show the value. Okay. So if we make a new object called dist mean and assign it the mean of the cars dist variable, if we put it inside of parentheses within our editor here, our console, note that it will print out what is inside of the dist mean object that we've created. However, if we did dist mean cars dist, and we didn't put it inside of another set of parentheses, it would not print out for us what was inside of the new object we've created. We can continue to draw ugly pictures. One such way is with the generic plot function and the dist tilde speed format. Note that dist tilde speed is a formula of type y by x. The first element, dist, gets plotted on the y-axis, and the second, speed, goes on the x-axis. Regression formula follow this convention as well. So once we get to week 10, we'll be seeing a little bit more of how this is set up, as well as in week 2 and week 4 if you do the advanced homework. But I provided this here as an example of how you could make a scatter plot and provide some interesting values. Okay. Oh, excuse me. I did not create our mean speed object before running this. So I'm going to run this. Show you that it goes, and we'll produce the same thing from the slides. But I will also break down what all is happening in this code chunk here. So, like I said, we're going to plot the distance variable by the speed variable, where speed will now be the x-axis and dist will be the y-axis. The data argument will take our data frame, cars. Our x lab will be speed in miles per hour. Our y lab will be stopping distance in feet. Our main title will be speed and stopping distance of cars. PCH here is the size of each point that is in our scatter plot. We also have this AB line argument, where the horizontal is the mean of the distance variable that we created just a second ago, and the color is fire brick. We also have another line which is vertical, which is our mean speed. This is our vertical line here, so it's along our x-axis, and the color is cornflower blue. There are a lot of colors in R. I recommend checking them out. They're on the slides, but you can also just say base R colors in Google, for instance, and it will show you quite a lot. I also think, I might remember off the top of my head, there's a colors function. Yes, if you type in colors and don't provide it any arguments to, like this, it'll print out in the console what all colors are available to you. But I would still recommend that you look it up so that you don't have to just guess and try to switch in cadet blue 1 and compare it to your memory of cadet blue with no 1, for instance. Okay, let's talk about the Swiss data set. We're going to switch gears to talking about the Swiss data frame that's also built into R, like the cars data set. First, we should use !Swiss to see what things mean. So I'm going to go down here. Move on from having that in my console, so I can just mash escape as if I had left off the thing in the 11 minus 2 example from earlier. We'll just use !Swiss. And here in the help pane, it will tell us a lot about built-in data sets. For instance, this is the Swiss fertility and socioeconomic indicators from 1888 data. Standardized fertility measure and socioeconomic indicators for each of 47 French-speaking provinces of Switzerland at about 1888. And it's a data frame of 47 observations on 6 variables, each of which is in percentage, i.e. in 0 to 100. Okay. Makes enough sense. We have a few things like common standardized fertility measure, the percentage of males involved in agriculture as an occupation, et cetera, et cetera. And then a little bit about where they got this data from. And this provides a little bit of an example of things you can do with the Swiss data set. Okay, now let's load it using the data function on Swiss. So data Swiss. Sorry, I would like lean all the way over here. My microphone is right in front of my screen. Note again that it is saved as a promise. It is a promise up until the point that we use it. Okay, next we're going to add chunks to our markdown document, inspecting the Swiss data set, defining the variables, and doing some exploratory plots using hist or plot. You might experiment with colors and shapes. One option that's available to us right now is to use the pairs function. So I will go down here and I'll show you a couple ways that you can make a chunk in an R markdown. So one for our code, right, is 3 backticks, then a curly bracket, and a lowercase r. And then we want 3 more backticks to close that chunk. And we can paste that right in there. We should probably name this, I don't know, Swiss pairs, and we'll run that. And then down here, it produces all of these pairwise comparisons of each of the variables in the Swiss data set. I don't highly recommend that you use this function very often, not only because of the, I don't know, smattering that this plot creates, but also just for oftentimes the data sets that social scientists will use will have more than 7 variables, and this will expand quite quickly. Oh, that's right. As saying, I was going to show you a different way that you can make code chunks. You can also type Control-Alt-I. This will produce an R code chunk for you. I don't expect that you'll remember all of these kinds of keystrokes, but I figured I'd get it out there in case you do remember. Note that pairs is a pairwise scatterplot function. It's good for a quick look at small data sets, but mostly useless for larger data. Yeah, don't do this on like all of the most recent CPS. A note about installing packages. Let's make a table that looks a little less codey in the output. To do this, we'll want to install a package called Pander. Packages contain pre-made functions and or data we can use. Our strength is in its wide variety of packages. In the console, we're going to type install.packages, and Pander is going to be our only argument. It's going to be in quotes. It's important that it's in quotes because it's actually checking against an archive for a very specific named thing. So when you're installing packages, the capitalization matters, as well as the spacing quite a lot. I will note that I'm recommending that we use Pander now, but there are other packages for creating really beautiful tables, but this one's really strong for our markdown, at least in the intro. So I'm going to go to our console. We're using the console and not the editor. You basically never want to put installations of packages in your editor for any kind of script that you write. You virtually, I'm trying to think of an example where you wouldn't want to do this, but you basically always want to have in the console be where you type install.packages. Note that I started to type install and it wants to autocorrect all the way to install.packages for me. This is a function of RStudio helping you, whereas if you were just using R without RStudio, it would not help you do this. So I'm just going to hit enter in order for it to autocomplete. Then I'm going to type one quotes and it will produce both. And type panda and enter. It'll run that. Okay. Great. So now that Panda is installed in my version of RStudio right now. Okay. Note that unlike the library command, the name of a package to be installed must be in quotes. This is because the name here is a search term. It is text and not an object, while for a library, it is an actual R object. Once you install the package, which we just did, you don't need to reinstall it until you update R. Consequently, you should not include install.packages in any R Markdown or R script. Okay. So we use the function library to tell our R instance that we are going to use this particular package. You only need to do this once during your session. So I'm going to go here, make sure that I have Panda ready to go. And then run this here, and it won't look especially magical to you if you run it just right in the editor. However, if you run it in the in a code chunk in your Markdown, it produces much nicer tables than if I just said summary Swiss. So I'll actually compare it to so here is the Panda table, and then here is the output if we didn't throw it inside of a Panda and specify a style as one argument and the size of the tables as another. So you can see why this is probably preferable to this description of the information. Note that we put the summary Swiss function call inside the Panda call. This is called nesting functions and is very common. I will introduce a method next week to avoid confusion from nesting too many functions inside each other, as I find it very difficult to read when there are many, many, many functions inside of each other. We can make the data look a little bit nicer this way. Using Panda, I would recommend trying out different Panda options until you get the widths just right. And for your homework, you're going to write up a Markdown file showing some exploratory analyses of the Swiss fertility data, which we showed how you can load in the Swiss fertility data. Upload both the .rmd file and the knit.html file to Canvas. You must upload both in order to get credit. You're going to mix inline R calculations, tables, R output, and plots with text describing the relationships you see. Include at least one plot and one table. You're encouraged to include more. You must use inline R calculations and references at least once. These are functions like nrow, which tells you the number of rows in a data frame, mean, which gives you the arithmetic mean, SD, which gives you the standard deviation, core, which gives you the correlation, median, which gives you the median, and min, which gives you the minimum value. And you may not hard code any numbers referenced in your text. Your document should be pleasant for a peer to look at, with some organization using sections or lists. And all plots are to be labeled clearly by giving arguments to your plotting functions. Use chunk options echo and results to limit the code and output you show in the HTML. Discussion of specific values should be summarized in sentences in your text and not as printed code and output. So you should also write up some information about what you're seeing in the plots and calculations that you're producing. And be sure that the output is rounded so as not to be absurdly precise, something like round x with the round function where x is to the 2 decimal places. The following week, you're going to be getting your peer reviews in, and this is the grading rubric for which with which you're going to grade. 0 is the person that you've been assigned didn't turn in anything. That's a 0. 1 is they turned in something. It was very low effort. It ignored many, many directions. 2 is a decent effort. They followed the directions, but there are some minor issues. And 3, they absolutely nailed it. If you'd like more explanation of these things in the grading rubric, they are available on the course website. That's it for week 1's lecture. I'm really hoping I don't need to re-record these again. I will try my best to continue troubleshooting in the next couple of weeks. I'll see you on Monday for the optional lab or on Wednesday for class and visualizing data. Thanks, everyone.